In the last video about RGB, we demonstrated how you convert XYY into RGB. So this time, let's do the reverse. Let's try to round trip that and convert RGB into XYY. Many of the same principles that we discussed in the previous video apply here. So let's start with the same value we tried in the last video. Let's start with white. And white, as you recall, is expressed in linear RGB as 100%, 100%, 100%. Okay, now the first thing we need to do is convert linear RGB into gamma weighted RGB. That's very simple to do. All you do is just reference the number and then make that number to a power of whatever the gamma is. In this case, I'm using 2.22 just as an example. So let's pick 2.22. Let's make that an absolute reference so I can copy it over. And there. And let's go ahead and copy that over. And let's change the formatting to percentage format. There. Now, as before, I want to round this so that we don't have problems with future conversions. So that's easy to do. Just type round. Parentheses, and then that'll be 1 decimal place in the percentage format. There. Okay, now we have linear RGB converted to gamma weighted RGB. Now you notice the numbers haven't changed, and as we discussed in the previous video, the reason for that is that since we're dealing at 100%, there's really no gamma that's used at this level. So that's why there's no change in the numbers. Now the next step is to convert gamma weighted RGB into XYZ. So the way you do that is similar to what we did in the previous video. We highlight the target cells and then we pick a formula. In this case, it's the mmult formula. And click OK. And the first array is the RGB values we want to convert. And the second array is the XYZ values of whatever gamut we're working in. Now remember, when we were converting in the opposite direction, going from XYY to RGB, we used the inverted values of XYY of the working gamut. Going in this direction from RGB to XYY, we just use the XYZ itself. So let's highlight that 3x3 matrix. Let's make that a absolute reference and then click Control-Shift-Enter. And there's our XYZ value for 100% white. Now the last step in this is to convert XYZ into XYY. The formula for that is right here. So it is, for lowercase x, it's uppercase X divided by X plus Y plus Z. Now, for lowercase y, it's uppercase Y divided by x plus y plus z. And then for uppercase Y, that doesn't require conversion. You just copy that over. There we go. So we got the same number that we started with in the last video, 3127, 329, 1.0, which is the standard white point for the Rec 709 gamut. Now, again, this works for color as well. So let's try red. So red is always expressed, and by the way, this is true regardless of which gamut you're using. Pure red at 100% is always expressed in the following way. 100%, whoops, 0%, 0%. Now we can copy this number down from the row above to get the gamma weighted RGB value. Again, it doesn't change because we're at 100%. Let's just copy this down to get the XYZ value. And we get this number. And then let's copy this down in order to get the XYY value. And looky there, we got exactly the same number that you get when you specify red in XYY in the Rec 709 gamut. And this will work for any color. Now remember, these conversions will change if you have a different level of intensity. So if instead of 100% red that we were dealing with, let's see what we get if we try 75% red. The X and the Y are the same, but the luminance is much lower. It's 0.1123. And we'll get another difference if we change the gamma. So if instead of 2.22 we pick, for example, 2.35, then again the XY value stays the same, but the luminance is lowered to 0.1083. So that's how you convert linear RGB into XYY.